Welcome back to the channel. In this video, we're going to build the app on AWS and just get it working. We're not going to worry about intricate details like making sure the secrets are properly secured, making sure the networking is properly configured. We're going to abstract these ideas, just use defaults, and save them for the next video. This video's purpose is just get you a working example on AWS that you can see in production and play around with it. To make it actual production ready for clients, end users, etc. That's all going to happen in the next video. But like I've said in previous tutorials, I hate when video tutorials will just give you the whole thing at once and walk you through each individual step because that's great, but I don't have 3 hours to build an app. I'd rather have a quick app I can build in 30 minutes or less, have it working, and then add on features as I need them. Because I doubt you need every single thing in this video. You probably don't want to pick and choose what you need. So I'm going to give you the quick and dirty, have everything, and you can customize and use production for features that you actually need and not just everything, saving you a lot of time. So with that being said, let's go and get into the video. Run the GitHub repo right here. It's going to be in the description below as well. First thing you want to do is clone the repo if you haven't already. Git clone, copy here, terminal, git clone, paste, and then you got it. And then go ahead and open up that in your favorite code editor. I'm going to use Visual Studio Code like pretty much everyone else in the world right now. Now, real quick before we get started, you can help me out a lot by doing a few simple things. Subscribe to the channel, like this video, share on platforms you use like Reddit, Discord, LinkedIn, etc. Start on the GitHub repo right here. Follow me on GitHub, and also sponsor me either on GitHub sponsors or scrolling down Patreon. You can either do one time, recurring, whatever you want. It helped me out a lot. I'm not making any money off these videos right now, and anything means a lot. So with that being said, let's get into the video. Now I'll pull up the code. Now, preface this video, we're not going to go through a lot of the code here. We've gone through the code in the previous video, breaking down the individual files. I made a specific video just for that in this video series because there's a lot of files to go through, a lot of configuration. We're using nginx, we're using Celery, we're doing a lot here. And instead of having to piece that into each individual video, I made one video for that you can reference back very easily. It's going to have timestamps for every single file, so you can easily reference which file you want to look back and get more information on. Now, that being said, in this video, we're just going to build the Docker files, build the components on AWS, and get it running. Okay. Now, to start off, the first file I want you to look at real quick, and again, we're only going to go through a few files here, is this .github workflows aws-ecs-deploy.yml file. The only reason I want you to reference this is because I don't want you to understand the file. I just want you to see where I'm getting all the names that I'm going to be using for the ECR repositories, the cluster, the service, the task definition, the container names. I'm going to pull them all directly from this file and copy and paste. Why am I doing this? Because in a video later on this series, we're going to automate deployments and updates to our application on AWS using this file right here. It's going to run what's called a GitHub action on GitHub automatically whenever we check in code. We can run it manually if we want. However we want to run it, we can. And this will automate deployments and updates, saving us a lot of time and a lot of errors. But to be able to facilitate that, the names have to match exactly. That's why I'm copying and pasting from here. You don't have to do this. You're free to do whatever you want. But if you want to follow in this video series and see the power of the GitHub Actions, the automated deployments, the CI/CD, as it's referred to in the industry, then you want to copy and paste as I'm doing here. And if you want to change them here and change them on AWS, that would work. Okay? This your.env file, this has a lot of different variables that we need for our different containers. If we have our Flask app, we need to be able to access the Flask config, the Flask app path, the Flask secret key, the Celery worker, Celery beat. We need to be able to access the Celery broker URLs, etc. We need this file, or at the very least these variables, available to our different containers. We're going to do it quick and dirty and just upload this file directly to S3. Is this the right way to do it? Production ready? Absolutely not, because all this stuff is plain text. In the production ready video, we're going to put them all into SSM parameter store, making them all secured. nginx.conf, you do need to modify this file for this video. Scrolling down this location, you need to uncomment this second line right here and comment out the first line, and same with right here and right here. This is just a requirement for running on AWS. So you're not actually referring about the container name anymore, as you were right here. You're just using localhost. They're all running in the same task definition, so you're using localhost. So you want to save this file, make sure it's saved, because we're going to be using this file when we build a Docker image. We see our Docker file. This is the file we're going to run to build our Docker image to put on ECR, Elastic Container Registry. Nothing crazy going on here. This is the file that's going to be used for Flask, Celery and the Celery worker. And finally, we have the Docker file for nginx. This is the file we're going to use to build the nginx Docker image that we're going to put on ECR in a separate repository. Okay, so those are our 5 files I wanted to go through. Make sure you change these values in nginx config, and this your.env file should have your values here already from the previous video. You should have your mail app password. You should have your mail username. If you don't have these, you're going to need to set these. And also, one more thing I want you to change that I failed to mention previously is you need to change this Celery broker URL. Running on AWS Fargate service, running locally with Docker. This is what we had previously because we were running locally on Docker. But now we're running on AWS, so we're going to uncomment this one and comment out this one, because now we're running on the AWS Fargate service. And again, we're using this guest at localhost, same as we're doing in this nginx config. This is just the way that Fargate necessitates that you use these URL strings. Okay, now that being said, we modified 2 files, your.env and nginx config. You have both these modified, then ready to rock and roll. Let's go on. Here we go. First thing, go to the AWS console. Go to S3. Now, real quick, I'm not going to recreate every single piece of this on the fly as I usually do in videos, because honestly, there's just so much. There's so much ease for manual error that I don't want to redo this video 100 times trying to make sure everything's perfect. I'm going to have things pre-created, but I'm going to explain everything in great detail and walk you through how you can create the components yourself as well. Now, here's my bucket, AWS Flask Celery. The way you would just create this bucket is right here, and then give it a name. It can be any name you want, doesn't really matter. It's got to be globally unique. You can leave all of this as is, and then create the bucket. Great, you have your bucket. Go into it. Now we're going to upload a file. Add files. Once you select your file, that your.env file, and upload it, you'll see it populated. And then you'll see it right here. I have my own file, default.env, that I'm using with my personal information, my personal mail app password and mail credentials. So you're going to have a different name here, your.env. Mine's going to be default.env. Great. So now we have all of our environment variables saved in a file. Step 1. Next step, let's go to Elastic Container Registry right here. You just go up here, you search for ECR. It's going to be the first option right there. Once you're in here, you're going to create a repository. Now, where are we getting our repository names? Go back, .github, workflows, aws-ecs-deploy.yml, AWS ECS-deploy.yml. Here's our 2 repository names. Here's the first one, here's the second one. So let's create the nginx one first, or actually let's create the Flask one first. It's a little simpler. So we would go here, create repository, and we just paste the name. You click create, great, you'll see it here. You click into it, and then you view the push commands. Now, make sure you have Docker desktop running. If you don't, you won't be able to build the Docker images locally on your machine. If you need to pause this video real quick to make sure Docker desktop is up and running, go ahead and do so now. Otherwise, let's keep going. Copy the first command, open up your terminal. Just paste it, click enter. Great, login succeeded. Next, Docker build. Now, we're able to just run this command as is because the default Dockerfile right here is just Dockerfile. So when you do the Dockerfile build command, it specifies the default name for the Dockerfile to build as just Dockerfile. So that's why we don't have to do anything special with this command. We will have to change it for the nginx, but we'll see that in a second. So we can just paste this as is. Okay, build succeeded. Copy the next command, paste. And finally, the last command, paste and run. Okay, mine was a lot quicker because I already have images there. I'm just overriding. Yours is going to take a little bit longer, but that's okay. So we're going to close this. You have a refresh. You should see your images pushed right here. Great. Next, we're going to go back to our repositories and we'll create another one, this time for nginx. So we'll go back to our aws-ecs-deploy.yml, copy the repository name for nginx, and create repository, paste, create. you'll see it here. Click into it and view push commands. Copy the first one, paste, a little redundant because we already ran it before. Now this Docker build, this is going to be different. Let's pull it up in here so we can see a little better. Just going to do a new file, zoom in a little bit so we can see this a little better. Great. Now, what we have to do here is we have to specify the file name for the Dockerfile nginx. And we can simply do this by just adding a -f, specifying the file name, then Dockerfile _ nginx. Copy this. Let me zoom out so we can see everything again. Because we see we named it that just right here, Dockerfile _ nginx, which matches what is right here. So we can take this command, paste it, and now we're building it specifically off that Docker image and that Docker file that we created. So we're letting it build. It's done building. Go back to AWS, Docker tag. Nothing needed to be done with this. And finally, Docker push. Because we already tagged it, we don't have to do anything else with the Docker push command either. And we just let it run. Okay, it's done pushing. Mine was probably a little faster than yours just because I already had the layers there. So we're going to close, refresh, and we see it's pushed fine. Great. Now, what's next? Now we have our repositories created. Now we need to create our task definitions on ECS. Our ECS task definitions are going to specify our individual Docker containers, as we did in our Docker compose.yml file. You can reference back to that file in the previous video right now if you want. In that file, we created 6 different containers, which we're going to do right now in our task definition. Let's go to task definition right here. So we have our task definition, and I'm just going to create a new revision. Now, you're not going to already have a task definition created. So what you're going to do is you're going to do create new task definition. Where are you going to get the name from? You can go to here. We'll delete this right now because we don't need it anymore. You can copy it from right here, AWS ECS Task Definition. So Control C, go back, and then paste it in here. Now for me, I already have it created. So you're going to stay where you're at and follow along from there and create it from scratch. I'm going to actually create a new revision from what I already have. So create a new revision, and great. Everything's the same except I already have the task definition family pre-populated. You pasted it in, and then I'm gonna have all the containers created already as well, and you're gonna follow along and create them one by one as we go through them. Okay, so let's do it. First thing, launch type, AWS Fargate. As I said before, I'll say it again. We're using Fargate because we're developers here. We're not trying to build all the infrastructure and have it all work and understand all the low-level computing, the OS updates, the memory allocation, all that jazz. We're just going to create Fargate, let AWS manage the updates, the infrastructure, everything for us, so we can focus on being developers. Great. Operating system, CPU, task role, everything's A-OK. Now, real quick before we go on, we actually do need to pause and change this ECS task execution role. We don't need to change it per se, but we need to at least modify it to allow it to have access to the S3 bucket, because by default, it does not. So we go to IAM now. You can just search for it up here, IAM, click into it, and then from there, you will select the roles option on the left. Once you're in here, you're going to search for ECS task execution role, the same one you'll see by default in this task role right here. What you're going to do is you're going to click into it. You're going to click Add Permissions, Create Inline Policy. So I already have it created here, but I'm just going to show you so you can follow along. Create Inline Policy. Great. So choose a service. We're going to select S3. Actions allowed. We're just going to select everything for read by default. Make it easier for our lives. In production, you probably want to be a little more specific. I'm not even going to go into that in the next video per se, but you want to be very specific about what actions you need. You can specify them here. I'm selecting read as a catch-all because we're not actually making any updates to the file. We're just allowing access to access the values, which is fine. Because in the production ready video, we're not going to use this option anyway. We're going to use SSM parameter store. Now for the object, we add the arms to restrict our object. Now, where are we going to get our arm from? The S3 bucket. Here's our default.env. Here's the resource arm right here. Go back, resource arm, and we can paste it right in. Make sure this matches what I already have. We go to the visual, S3, scroll down. Here's the same one that I already have specified here. So the policy is fine. Add arms, Great. Scroll down. Next. Policy name. Give it whatever you want it. What did I call this? I called this AWS Flask Celery S3 Access. But again, you can call it whatever you want. Create policy, and then you're good. I don't need to create this because I already created it. I'm going to go back to my ECS Task Execution role. Then once you create that, you should see a second one right here. So now what we've done is we've given access to the ECS Task Execution role assigned to our task definition to be able to access the S3 bucket. We're going to see exactly where we specify access to the S3 bucket in the container definitions as we go through this. So keeping that in mind, the first container we're going to do is nginx. Here's the name. Where are we getting it from? Again, it's all coming from the same file. Right here, container name. Zoom in a little bit, make it easier to see. Task definition container name, nginx. Go back, paste that in here. Image URI, where are we getting this from? Elastic Container Registry. Here's our ECR nginx. Click the latest, copy the URI, and we can just paste that in right there. Great. Essential container, yes. What does this mean? It means if this container fails, the whole task definition should fail. Because nginx entry point to our application is vital to the service, we want the whole application to fail if nginx fails. That's why essential container is set to yes here. Container port, 80, port name, nginx. We're just matching the name of the container up here. And app protocol, HTTP. Great. Scrolling down. We don't actually need any environment variables for the nginx container because it's all self-contained. It doesn't access any of the Flask application code, the Celery application code. It's just running its own configuration. Use log collection by default is disabled. I highly recommend enabling it because what this will do is will give you logs when you're actually running your containers on ECS servers to be able to see the logs of each of the individual containers. Because if you have problems with anything, you need the logs to be able to understand what's going wrong. If you don't have the logs, you don't know what's going wrong, how it's going wrong. You just see that's failing. You have no other information. So it's always advisable to use this use log collection. Scrolling down, Docker configuration, we have none because there is no Docker command for this. So we leave that blank. Next, we have our Flask application. Flask app, where's it coming from? Right here. Copy paste, image URI. Because we're done with nginx, we actually need this as another tab anymore. We just go straight to here, Flask Celery app. Here's latest, URI. And we just copy paste that in right there. Again, essential container, vital to the whole service. Container port 5000, port name, Flask app. Just copy and paste from the container name, TCP, HTTP. Great. Now, we have an environment file. Where we specified that? Right here. Where's that coming from? Go back to S3. Here's our ARN, the same one we specified in our inline policy for our IAM role for the ECS task definition. We're going to paste that same ARN right here. Great. So we have our ARN specified. What could we have done instead? Could have gone to add environment variable and type each one of the environment variables one by one. For example, go to your.env, go to type Flask secret key, go here, go back, copy this, paste, and then do this over and over for each individual one. Is this advisable? No. Why? Because mail app password, this is your app password you've given to programmatically access your email. Do you want this in plain text right here where anyone can see it? No, you don't. You want this in SSM parameter store or AWS secret keys. This allows you to encrypt the individual value so your application can only access if it has permissions to. It's much more secure, is a recommended approach. But again, this is not production ready. It's just getting working. So we're going to do the easiest approach possible. Just upload the entire environment variable file to S3 and then access it, give access right here. So scrolling down, use log collection like always, highly recommend. Then the Docker configuration. Here we have our specific Docker command. And put it right here so we can see a little better. Gunicorn -b 000 port 5000 project.app port Flask app -- workers 5 -- timeout 100,000. This is just copied directly from the Docker compose.yml file. I just removed the new lines and the commas around each command and just copy and paste right in here. You can copy and paste this from the Docker Compose. You can type it out right here if you want it from the screen. Whatever you want to do, whatever's easier, you go ahead. There's our command. Scrolling down, now we have RabbitMQ. Here's our image URI. Again, same thing from Docker Compose.yml. Central container, yes, this is the message broker. Without it, Celery will fail. Container port 5672. Default, RabbitMQ, TCP, HTTP, same as all the rest. Scrolling down, no environment variables needed, so nothing to do there. Use log collection, highly recommend. Docker configuration, nothing needed because the Dockerfile is self-contained. It's coming directly from Docker Hub. It's not something custom from us. Next, we have Celery Worker, image URI, same as the Flask app. Copy paste, essential yes. Scrolling down, environment variable, yes, S3. Copy the ARN. Control V. Scrolling down, use log collection, yes. Scrolling down, Docker configuration. This is the longer one. You just copy and paste this directly from the Docker Compose.yml file, removing the commas and the new lines, or you can pause the video, copy it right here, and then paste it in if you want. Whatever's easier. Move it out a little bit so it's a little easier to read. And there you go. Scrolling down, Celery beat, same thing, same URI. Remember, there's 3 containers that share the same Docker file: the Flask app, the Celery worker, and Celery beat, which we're seeing here. Central container, we're going to say yes. You could say no here, it's not absolutely necessary. Scrolling down, we do need the same env file, so go here. Here's our ARN. Control A, Control V. Again, yours is going to say your.env. But I'm using default because mine has my own specific ones. Use log collection, highly recommend. Docker configuration, here we go. Paste right here, easier to read. Again, it's all coming from the Docker Compose.yml file. You can copy it from there, remove the new lines and commas, or you can type it from here and then paste it into the command. Scrolling down, last one, Celery Flower, Docker Hub, repository, central container. We're going to say no, it's not absolutely necessary. It does help. Container port, port name, great, right here. Again, S3, copy, paste, great. Use log collection, highly recommend. Docker configuration, copy right here, blow it up so it's easier to read, and there we go. Celery -s broker, guest at localhost. Where's this localhost coming from? Again, we had to change this because we're running on AWS Fargate and not running locally with Docker Compose anymore. So we use this localhost 5672, flower, port, and the URL prefix. Great. So once you have that, you can obviously copy again from Docker Compose, or you can type it off the screen and then paste it into there if you want, whatever's easier. Okay, so you have all this created, then you can create your task definition. Once it's created, you'll see right here, say AWS Flask Celery Task Definition :1. Here's my first one. I created a few different revisions as well as modifying things and testing things, but you'll have yours. Great, let's take a quick pause. What have we done so far? We've created our S3 bucket with our environment variables. We've created our 2 Elastic Container Registry repositories for our Docker images, for nginx and our Flask app, which also serves for the Celery worker and Celery beat. Now we've created our task definition, specifying each one of the 6 containers, the 6 Docker containers we're going to be running. Next, we can go to clusters. We can create our ECS cluster. The ECS cluster is going to run a single ECS service. The ECS service is going to run a single ECS task definition. That task definition is going to run each one of those individual 6 Docker containers that we specified. And this will allow us to finally access our application. So let's give it a name. Where's the name coming from? Same place as all of them. Here's our ECS cluster name. Copy, paste. We don't need a namespace. Fargate, same as the task definition. You can leave this on if you want, doesn't really matter. Turned off for now, make it a little easier. And give this a sec to finish. Give a little refresh. Shouldn't take longer than a few seconds. Let's refresh the whole page real quick. There we go, we see it. Click in, services, let's create our now ECS service. Okay, launch type, we're gonna leave it right here. We're not gonna use this capacity provider This allows us to scale up and scale down instances depending on load. This is a very simplified example. We're not going to worry about that. Scrolling down, it's a service, task definition, the latest revision. If it's not, make sure you do select the latest. That's where you have your latest code. Service name, where are we getting it from? Same file as always. Copy, paste. There's our service. All this stuff we're going to ignore. Service connect, not necessary. Networking. This is where I talked about using things as is. We're going to use the default VPC. We're going to use the default subnets. We're going to use the default security group. This public IP is turned on. All this stuff is not recommended in production. We're just going to take it as is here because we're trying to make a working example. So we're going to hand wave this away and just say, yeah, we're going to use the defaults and it's going to work. Great. Nothing to do. Create. Now the service is spinning up. Let's let it run. Give it a quick refresh. Here's our service. We can go to our task right here. No tasks are running yet. Now, if you want to see your logs, you can see the logs for each container as they're running, or any container. If you have any issues running your application, your service, your task, you can see the logs here. Also, once the task is spinning up, let's give it a refresh. We see our 101 task is provisioning. You can also see the logs in here. For any container, you can see the logs as they come in. Go back to task. You'll see down here, here's each one of the individual Docker containers for that task. If any one of them fail, you'll see them fail with status here. So if you're having trouble running it, make sure you check which container is failing, and then you check the logs either in the task definition or at the service level. And you go to the specific container that was failing. Okay, let's go back. Let's give it a quick refresh. Okay. Scroll down, we see all the containers are running successfully. So next we can go to our AWS service, configuration, networking. First thing I want to do is go to the security groups because right now we have no way to access our application. Because for our security group, by default, it only allows inbound traffic from itself. We need to allow inbound traffic on port 80 to the security group because that's how we're going to access our application is on nginx port 80. So we're going to add an inbound rule for our security group on port 80 from RIP to access our application. So edit inbound rules, add rule, custom TCP, port 80, and we're going to say my IP. Now I'm not going to expose my own public IP, so I'm going to do 0.0.0/0. Highly don't recommend doing this in production because this gives unfettered access to your application. It even tells you down here, you shouldn't be doing this. But it's just an example. You don't do this. You do my IP. Save rules. Great. So we have that set. Go back to our task. Scroll down. Click into our task. Go to networking. Here's the public IP. We're going to open the address. Here's our application. Great. Next, we're going to go to send email. Recipient. Just going to put in my email. Subject test, message body test, send email. Great. Email is sending. I'll verify that in a second. Let's also check out the Flower dashboard. And we see Flower, see our tasks that are processing, succeeded. These are all coming from Celery Beat. We also know because they're coming from the one that we sent with the send email. Send async email, here's one, and then test print the Celery Beat. That's happening every 10 seconds. That's happened 13 times. Great. So let's go through what we've done. We started with S3. We uploaded our environment variable file. Next, we created our 2 ECR repositories. Then we created our ECS Task Definition with our 6 Docker containers. Then we created our ECS Cluster, ECS Service, and had the ECS Service point to the ECS Task Definition to spin up the 6 Docker containers. We modified the security group for the ECS Service and ECS Task Definition to allow incoming traffic on port 80 from your IP. And also we modified the ECS Task Execution role assigned to our ECS Task Definition to be able to allow us to access the S3 bucket with our environment variables. Great. Now, I'm not going to go through how to set up Redis specifically. It's pretty simple. All you would do is in your.env, you just modify this Celery broker URL right here to Redis. And then also in your task definition, Celery task definition, create new revision. You would also modify to not use RabbitMQ, but instead use Redis. So you would delete the RabbitMQ container and you would create a Redis container. Again, using the port mappings needed for Redis, and you don't need an environment variable. You would use log collection, and you don't need a Docker configuration. You would also have to modify, scrolling down, the Celery flower Docker configuration command to point to the Redis broker, as we did in the getting it running locally command. And you can reference back to that if you need. Okay, so that's the video. Hope you learned a lot. If you have any questions, leave them below. Be happy to answer. And stay tuned for the next video because we're going to go through how to set up all this in the production ready sense without relying on the default values and configuration provided by AWS, but doing it in a way they could actually deploy to production today. Okay, thanks for watching. Stay tuned for the next one, and I'll see you there.